Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. To doctor. So this is my answer for Simulink assignment. So for the first question, we need to model the equation and find the transfer function. So first, I list the assumption I made. First is constant density, constant heat of reaction SCP, which is from the question given. Also, I assume the reactor is perfectly meets the shaft work and heat loss is negligible. Also, the concentration dynamics for energy balance is neglected. After that, I list the reaction rate for each CSTR. Since CSTR1, CSTR2 is first order, while CSTR3 is second order. Then I list the mass balance equation for each CSTR, which does not include the component A. After that, I include the component A mass balance. And then I can use the information from the mass balance equation general to simplify the equation for component A mass balance. Then I can get that CSTR1 is equals to V1 TCA1 over dt equals to F0 CA0 minus F0 CA1 minus K1 CA1 V1. And for the rest of CSTR2 and CSTR3. After that, I go through for the energy balance, which general is rho Cp Vi dti over di equals to F in rho Cpt in minus rho Cpt out plus Q minus if reaction Rivi. I can simplify the equation for each CSTR2 for CSTR1 is dt1 over dt equals to F not T0 over V1 minus F not T1 over V1 plus Q1 over rho Cp V1. And for the CSTR2 and CSTR3, as I said, for the energy balance, I neglect the concentration dynamics to simplify the equation. After that, I transfer the function for both mass balance and energy balance. For mass balance, I put the inlet is F0 while the outlet is CA3. And first, I linearize around the steady state as same as the rate of reaction. And I input the steady state equation and minus the general equation minus the steady state equation to get the differential equation to linearize the equation. Also, I forgot to mention that I assume the volume is constant in transfer function derivation. And then I get the CSTR1 and CSTR2 and CSTR3 equation, these three equation. After that, I Laplace transform for these three equations to get CA1S, CA2S, and CA3S. After I get CA1, CA2, CA3S, I need to find the target, which is CA3 over F0. Then, also I forgot to mention that tau value is equals to Vi over Fi for each CSTR. Then I can find the CA3 over F0, and I input the tau value and I find the final transfer function. After that, I go through the energy balance, which I put the inlet is Q and the outlet is T3, and I linearize around the steady state, and I linearize equation 4, and I introduce the new tau for energy balance, which tau I equals to Vi over Fi minus 1. Then I can find the final CSTR equation is dt1 over dt minus equals to negative 1 over t1 tau 1 over t1 equals to times t1 cap plus q cap over rho cp1. As for the rest of CSTR2 and CSTR3, and then I find the t1s Laplace transform for t1s, t2s, and t3s. In order to get t3s over q1s, I multiply t1s with t2s and t3s, and I find the tau value and I put the tau value as for the rest of parameters, and then I can get the final transfer function, which is this. And with these two transfer function of energy balance and mass balance, I create a different column for each mass balance and energy balance, and block diagram including the performance, and this is the subsystem for mass balance and this is the subsystem for energy balance, and this is the control system using P, Pi, PID, and the performance value for each one. And I take out the value for performance of each ITAE, IAE, ICE, and then I can conclude that for both energy balance and mass balance is P controller.